our objectives is compare linear, quadratic, exponential models. Given a set of data, decide which type of function models the data and write an equation to describe the function. All right, in the real world, people often gather data and then they must decide what kind of relationship, if any, they think best describes their data. So here, this is some data down at the bottom. It says how to recognize a type of graph from a table. Now, you could actually just plot the points on a piece of graph paper to figure out what type of graph it is, but sometimes you don't have enough data points to really tell. So sometimes it's easier to use this method. It says to recognize if a function is linear, quadratic, or exponential without an equation or graph, look at the difference of the y values between successive integral x values. If the difference is constant, which means it's exactly the same, the graph is linear. If the difference is not constant, but the second set of differences are constant, the graph is quadratic. If the difference follow a pattern similar to the y values, the graph is exponential. See the examples below. Okay, so if you take a look at the first example, the x's have to go up by the same thing. If the x's don't go up by the same thing, you can't use this method, okay? But if you take a look here, the x's do go up by the same thing. They all go up by 1. -3 to -2, -2 to -1. So then we check out the y values. So the difference. So -7 minus -5 is 2. -5 minus -3 is 2. -3 minus -1 is 2. -1 minus 1 is 2. Now, I could put a -2 in here on all of them. It doesn't really matter because they're all the same. So this is called the first difference. This is the first difference. And they're all the same. That means this set of data is linear. Now, here's the graph of all that data. And it sure does look linear, doesn't it? So that is how we tell if something is linear or not. If the first difference is the same, it's a linear function. If you graph it out, it's going to come out to be a straight line. Okay? So now let's take a look at another set of data. Do all of the x values go up by the same thing? Yes, they do. Okay, so I'm going to start on this side this time because I think this is how they do it. 9 minus 4 is 5. 4 minus 1 is 3. Right away, I know it's not linear data because they're not the same. 1 minus 0 is 1. 0 minus 1 is -1. 1 minus 4 is -3. 4 minus 9 is -5. They're not all the same. So the first difference is not the same. That means the data is not linear. Okay, that's what it tells us. Now let's take a look at the second difference. So that means I just take that list that I just came up with. So 5 minus 3 is 2. 3 minus 1 is 2. 1 minus -1 is 2. -1 minus 3 is 2. -3 minus is 2. This is called the second difference. The second difference is the same. It is a parabola, or it's quadratic data. And if you graph this data out, look at the graph. It is a parabola. It makes sense. It works. Now, there's no such thing as the third difference and fourth difference and fifth difference and all that kind of stuff, okay? So, but an exponential function, if your x values are always going up by the same thing, -3 to -2 to -1, so they're all going up the same. But if your y values are being multiplied by the exact same thing, -1/8 times 2 is 1/4. 1/4 times 2 is 1/2. 1/2 times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. This is what is called an exponential function. And the ratio is equal to 2. So we know what the ratio is. And from what we've been doing already in this class, we should be able to write an equation for this, shouldn't we? We know the ratio is 2. We know that it crosses at 0, so isn't this just the equation? Y is equal to 2 to the x. If I put 0 in there, I get 0. Or, I'm sorry, anything to 0 power is 1. If I put 1 in there, I get 2. If I put 2 in there, I get 4. If I put 3 in there, I get 8. So my equation is this. But now, that's because I remember a little bit of what we've been doing. So that is how you tell if the data is linear, parabola, or quadratic, or exponential. So in these examples here, it says, based on the difference in y values, identify the graph as linear, quadratic, exponential, or none of them. All right. So in this first problem, I always do exponential first, because if I can multiply 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. This is exponential. No question about it. This is an exponential set of data. And that's how I always do the exponential first, because it's really easy to do. Now this one, 1 times 6 is 6, 6 times 6 is not 11. So this is not exponential. Okay, so then I'm going to do my differences. Okay, so I just draw these in here. All right, 16 minus 11, that's 5. 11 minus 6, that seems to be 5. 6 minus 1 is 5. 1 minus -4, that's 5. -4 minus, that's 5. That's 5. This is a linear set of data. Awesome. So it's fairly easy to figure out if something is exponential, if it's linear, just by looking at the data, or if it's quadratic. Okay. Now in this problem, if you're given the graph, right away you should be able to say that this is a exponential graph, right? This definitely is coming down, it's getting closer and closer to 0, never crosses it. Okay, so sometimes just graphing it out helps. But now we're going to be talking about Desmos. After deciding which model best fits the data, you can write a function. Recall the general forms of linear, quadratic, and exponential functions. Now, if you're using Desmos, you have to know this, because it's going to ask you what type of function you're going to put in, and it doesn't ask linear, quadratic, exponential. You have to put in y is equal to mx plus b, or y is equal to ax squared plus bx plus c. If you want a quadratic, if you want an exponential function, you have to put in y is equal to ab to the x. So that has to, you have to be able to do that when you're using Desmos. I'm trying to get Desmos up on my screen so we can use this in just 1 second. Okay, I'm going to share it with you in just a bit. All right, so steps of finding an equation for a set of data. Step 1, decide which type of data it is, linear, quadratic, or exponential. So we need to know that. Input your data into a graphics calculator. I'm going to do that in just a bit. And then what equation do you use? And then you have to tell it. Okay, I'm going to go through all those steps. So in Desmos, first thing you're going to do is you're going to put in a table. You're going to hit table. You're going to go up to the plus sign. You're going to hit table. You're going to put your numbers in. Okay, and it will plot the points out for you. Okay, and then your next step with Desmos would be to write. So since we know that this is a linear function, we're going to tell it. We're going to say y1, and then the tilde symbol, m, and then x1. Why do we use x1 and y1? Because that's what's in our table, x1, y1. So we have to tell it plus b. So if you tell it that, hit enter, it's going to tell you what your m value is and what your b value is. So my equation is y is equal to 2x plus 2. Boom. There's my equation. And how do you check yourself? Just plug your equation into, into the table. And I'll show you how to do that in just a second too. Okay, so for those of you that have made it through so far with me, this problem is on your assessment this week. So that I will know if students watched it or not, because I'm going to go through this problem with you guys. Okay, it says the table shows the average price of movie tickets in the United States from 2001 to 2010. So in 2001, the average price for a movie ticket was $5.66. In 2010, it was $7.89. Okay. It says use a graphing calculator to find the regression model for the data and graph the model with the scatter plot. When you insert your x values, please use x equals 1 for 2001, x equals 2 for 2002, and so on. Okay, got that. Find a linear regression, okay, and find an exponential regression. So we have to find both of them. All right, so here we go. I am going to share my screen. I'm going to share, let's see here. If I go from here, go to here, share application screen, Chrome tab. All right, so hopefully you guys should be able to see this, and it does look like you can. Okay, so what I'm going to do first thing, I'm going to put my data in. So I go to this plus sign, hit the plus sign, table, put it in there. Okay, my x values. And this is going to take me a little bit of time because I'm not real great at typing. So my x values are going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? And for 2001, 2002, so forth and so on. Well, 2001, it said the average ticket price was 5.66. In 2002, 5.1. In 2003, 6.03. 6.21. 6.5. 6.41. 6.55. 6.55. 88. Sorry, it's taking so long, guys. 7, and I was going to put this in before, but then I thought I better show you guys how to get the table first. 7.0, and my last one is 7.89. 7.9. Now I better get rid of this because it's no value for that. Okay, so my next thing is here's my here's my values. Okay, it looks like it could be linear. It looks like it could start going up exponentially. Okay, so it asked me to write both the equations. So I'm going to do the linear one first. So I go down here. Linear is y is equal to mx plus b. But remember, x1, y1. So I'm going to tell it y1. And you have to find the tilde symbol. It's not an equal sign. It's a tilde symbol. You go to your keyboard. Tilde is, I thought the tilde was right on here, but I guess not. I think it's an ABC. ABC. And then this is your tilde symbol. So tilde. And then mx1, right? We have to use mx1 plus b. Boom. It just wrote my equation. So my equation, if you look at this, my equation, my m value is 2.412 and 5.28. So my equation, if I had to write down my equation, is, and I'm going to write it down, y is equal to 0.2412x plus 5.285. Boom. That's my graph for a linear function. Now, it asked me to write an equation for a exponential also. So again, y1 is equal to, now this time, exponential function is a times b to the x value, right? So I don't think I have to put a multiplication in there, and then raised to the x1, right? x1. All right, so where'd my graph go? Oh, I didn't put a tilde symbol in there. Shame on me. That's going to change it because it won't work that way. Okay, there we go. Now we have it. So what is my equation for my exponential function? Well, it's going to be y is equal to, my a value is 5.367 times my b value is 1.03759 to the x power. So now I have both my equations. So you can answer the rest of the questions because there are some questions I didn't put the whole problem down, but it really, I just answered most of the stuff that you need for this. Whew. I hope you guys enjoyed this one. Make sure you come to the main lesson on Monday, and we'll go through all the practice problems for the week. You guys have a great one.